Today's topic of discussion is velocity and acceleration of a particle in plane polar coordinate system. Let's see here it is a xy plane, and in that plane a particle is moving. At any instant, let p is the position of the particle, and the position vector of the particle with respect to the O, which is the origin of the coordinate system, is r. This is the position vector of the particle, and the direction of r, in which direction r is increasing, this is represented by r cap. And this position vector of the particle makes an angle theta with the x-axis, and the distance of p with respect to the origin of the coordinate system is r. So the p point has coordinate xy in Cartesian coordinate system, that means in xy coordinate system, and another coordinate of p is r theta, and it is in plane polar coordinate system. So there is two unit vector. One is in a direction in which direction r is increasing, and another one in a direction in which theta is increasing, and theta increasing in that direction, and it is perpendicular to r. This is the angle between theta cap and r cap is 90 degree. Now the component of r in the direction of the x-axis, this is r cos theta, since the angle is theta, and also the component of r in y direction is r sin theta. Now the position vector of the particle in Cartesian coordinate system can be written as r is equal to xi plus yj, and here x is equal to r cos theta, so x is equal to r cos theta plus y equal to r sin theta j. So this is the position vector of the particle in plane polar coordinate system. Now the unit vector in unit direction r is increasing, and this is r cap is equal to r vector by magnitude of r. We always get a unit vector if a vector is divided by the magnitude of the vector, then we get the unit vector in the direction of that vector. So the unit vector in the direction of r is r vector by magnitude of r. So this is r cos theta plus r sin theta, this is the r cap unit vector, and this is equal to cos theta I plus sin theta j. And since theta cap is unit vector in a direction perpendicular to r, so theta can be expressed as cos 90 degree plus theta, here cos theta, but since theta cap is perpendicular to r, so cos 90 degree plus theta I and sin 90 degree plus theta j. And this is equal to cos 90 degree plus theta, means it falls in second quadrant. This is 90 degree and this is 90 degree plus, so falls in second quadrant, and this is the position of the sine, all sine 10 cos, so this is the position of sine. So and since 90 degree, so cos changes into sin theta, and negative sign will become, so minus sin theta I plus cos theta j, sin 90 degree plus theta. Since the second quadrant is the position of sine, so just changing sin 90 degree cos theta j. Now when particle moving in a plane, the direction of r and theta may change with time. So the rate of, I want to calculate the rate of change of unit vector, both r cap and theta cap. So this is the dr cap dt, and this is equal to ddt of r unit vector r cap equal to cos theta sin theta j. So this is cos theta I plus sin theta j, and this is equal to since they are function of theta, but we are going to differentiate it with respect to t. So this is d theta cos theta d theta dt I plus d theta sin theta d theta dt j. And the differentiation of cos theta with respect to theta, this is minus theta, and d theta dt is represented by theta dot, and d theta sin theta is equal to cos theta theta dot j, and this is equal to here theta dot is common, so minus sin theta I plus cos theta j, and this is equal to r cap dot is equal to theta dot, and this is equal to theta cap. So r cap dot is equal to theta dot theta cap. Now d theta cap dt is equal to d dt of theta cap equal to sin minus sin theta cos theta j. So here written minus sin theta I plus cos theta j, and d theta minus sin theta d theta dt I plus d theta cos theta d theta dj, and this is equal to minus sin theta differentiation with respect to theta cos theta, and d theta dt theta dot I, and differentiation of cos theta with respect to theta is minus sin theta and theta dot j. So the theta cap dot equal to here we have taken theta dot common, so cos theta plus sin theta j, and cos theta plus sin theta j is equal to r cap here, so minus theta dot r cap. This is the theta cap dot. Now I want to calculate the velocity of the particle. Here the position vector of the particle with respect to the origin is r, and it also represents the displacement of the particle from origin of the coordinate system. So r vector r cap, it represents the displacement of the particle, and it expressed as this is magnitude of the displacement, and this is the direction of the displacement. So the velocity is equal to dr dt, because you know the velocity of the particle is equal to the rate of change of displacement, and here r vector is the displacement, so v is equal to dr dt, and this is equal to dr dt r cap plus r dr cap dt, and dr dt is equal to r dot, and r cap equal to r cap plus r theta r, and this is dr cap dt, and dr cap dt is equal to r cap dot, and this is equal to theta dot theta cap, and here substitute the value of dr cap dt equal to r theta dot theta cap. So this is the expression of the velocity of the particle moves in a plane. So there are two terms in the expression of the velocity of the particle. One is radial term, so this is called radial velocity, and another one transverse velocity. And the expression of the velocity, this is very important, and it is very important to study the motion of a particle when particle moves in a center force field, and I will discuss about center force field in next class. So please memorize the expression, the velocity of the particle when particle moving in a plane. Okay. Now I want to calculate the acceleration of the particle, and it is also very important to study the equation of motion of a particle moving in a center force field. So it is also try to memorize, and it is very important. And we know the acceleration of a particle is equal to the rate of change of velocity. So acceleration A equal to dv dt. V is the velocity, so this is the rate of change of velocity, or d dt, and we know the expression of the velocity r dot r cap plus r theta dot theta cap. Two terms here, radial and cos radial terms. So the expression d dt of r dot r cap plus r dot dr cap dt, plus for the second term, first differentiate r with respect to 2, so dr dt theta dot theta cap plus second time when r theta cap is constant, so d dt of theta dot plus r theta dot is constant, differentiate d dt and differentiate theta cap with respect to dt. So this is the expression, and d dt r dot is equal to r double dot r cap, and r dot dr cap dt, we know the change of rate of change of r cap is here, and this is r cap dot is equal to theta dot theta cap. So I substitute here the value of dr cap dt, and this is theta dot theta cap. So finally the expression become r dot theta cap, and here dr dt r dot and theta dot and theta cap, and r here differentiate theta dot with respect to time, r and theta cap is constant, so this is theta double dot theta cap plus r theta dot, and d theta cap dt I already derived the expression theta cap dot is equal to minus theta dot r cap, and substitute the value of theta cap dot, and here this is minus theta dot r cap. So there are two terms in the direction of r cap, and this is r double dot and another minus r theta dot square. So this is the component of acceleration in the direction of r cap, and another term is r theta dot and r dot theta cap, and there are two terms, so 2r dot theta cap. So the acceleration of a particle, when a particle moves in a plane, there are two terms. One is radial terms, and this is called a radial acceleration, and this is cross radial acceleration, and it is also called transverse acceleration. So this is written as ar r cap plus a theta dot theta cap, and a radial acceleration term also has two terms. One is r double dot, and it represents the acceleration of particle in which direction r dot is increasing, and this is the it is direction away from the center, and another one is in which direction theta dot is increasing, and this is actually comes due to the change of theta, and the direction of this term toward the center, but r double dot has the direction away from the center, and this is the radial acceleration. Another one is cross radial or transverse acceleration. There is also two terms. One is r theta double dot, and this is in the direction in which direction theta dot is increasing, and this is called the angular acceleration. And 2r dot theta dot, this acceleration comes mainly due to the interaction of velocity of the particle and angular velocity of the particle in which frame particle is moving, and this is called Coriolis acceleration. And this acceleration is coming when particle is moving in a non-inertial frame, rotating frame. So this expression of the acceleration come when particle moves in a non-inertial frame, rotating frame. So the final expression of the acceleration is here, and this is very important, and it also required to study the motion of particle when particle moves in a central force field. So please try to memorize the expression. Thank you.